A car moving this way, we'll call that car A. We got a car over here moving this way, call that car B. So this is going to be the velocity of A with respect to the ground, and this is going to be the velocity of B with respect to the ground. And what should we make that? 60 miles an hour. What direction is that? East? Okay, and then the velocity of B with respect to the ground. And what should we make that? 50. Due north. And what I want is the velocity of car A with respect to car B. The idea here is that it depends on the observer, right? So that's what this means with respect to. So if I'm doing this, if I'm going this way, my velocity with if I'm walking at 1 meter per second in this direction, I see you as moving that way at 1 meter per second. You see me moving this way at 1 meter per second, right? So a lot of it depends on the observer. So let's write that here. So the velocity of 1 with respect to 2 is going to be negative of the velocity of 2 with respect to 1, right? So I'm going this way, but I don't think I'm moving, right? When I'm moving this way, I think you're going that way at 1 meter per second. You think I'm going this way at 1 meter per second, right? It's relative. So I see your velocity with respect to me as 1 meter per second in that direction. You see my velocity with respect to you as 1 meter per second in that direction. So this equation is handy. When you flip the observer, you get it just shows up as being in the opposite direction. So what we're looking at here is how does car A, what does car A look like if you're sitting in car B, right? What does the speed look like? What does the velocity look like? What do you think? What direction is it going to go? Just draw it on your, if you're sitting in car B, looking at car A, what direction does it look like it's going? So what's the verdict? F, we agree? Because if you're sitting in car B, what's happening? The cars are closing on each other, right? B is going up, A is coming to the right, so the cars are coming together. So if you're in car B, it looks like car A is coming toward you because they're almost going to meet at the intersection there, right? Not quite, maybe it depends how far away they are, right? But I would say this is our answer because it looks like if you're in B, it looks like A is coming toward you. So let's do it. All right, we're back. We're ready. So we kind of looked at the situation, came up with the fact that it's probably going to be pointing down and to the right. So F, let's see what we get. Our formula, the velocity of A with respect to B, that's what we're trying to find, right? Why don't you write out that formula using sort of our master equation for velocity addition? What two vectors are we going to have to add to get this resultant? This is the result we're looking for. No, we're going to forget about that. We're going to actually solve this problem now. Given the velocity of A with respect to the ground, given the velocity of B with respect to the ground, we are finding the velocity of A with respect to B. Yes. Okay, so what? Check with your neighbor. How did they write out this equation? First vector is what? AG. The second vector is? Is that right? First vector, let's do our check here. First subscript's the same. Middle ones? Are those the same? Are the ones in the middle the same? So we got a problem here, right? Our master formula is that the first subscripts have to be the same, the last ones have to be the same, and the ones in the middle have to be the same. So this isn't working for us. So let's try again. Velocity of A with respect to B is going to be the vector sum of A with respect to the ground and the ground with respect to B. Does that work? Let's see. First one's the same. Last one's the same. Ones in the middle are the same. Okay, so now, so first get the equation right. This second one is right. Right? It fits our form. Now, let's see what we know and what we don't know. We know the velocity of A with respect to the ground, right? That's given. But the velocity of the ground with respect to B is not given. What is given? B with respect to the ground. And we know this. We know how to get it into the form of ground with respect to B. We can just add the opposite. So this is going to be the same as the velocity of A with respect to the ground plus the opposite of VBG. We okay with that?